Welcome to our presentation of LADS, the Laboratory Agnostic Device Standard. My name is Dirk Hebel, and I'm Head of Product Management at Inforce AG, and since over a year now, part of the SPECTARIS working group, Connected Laboratory Devices, where we have developed the standard and are now working to implement it. Together with me, Heiko Oehme from Analytic Jena will present the standard to you today. Heiko, do you want to take over from here?
Thank you very much for this introduction. My name is Heiko Oehme. I work for the Analytic Jena AG, and the Analytic Jena is a manufacturer of measurement instruments for the laboratory. And in this context, I'm working together with Dirk and a lot of other people in this working group to develop this LADS standard. There are several studies that have dealt with increasing efficiency in the laboratory, and a central point here is the digitalization and automation in the laboratory. The McKinsey study mentioned Booth, for example, sees a potential of up to 50% cost saving and 70% saving in the time needed to provide laboratory results. Here, the initiative for the Laboratory Agnostic Device Standard comes in. In addition to the standardization of the device communication, special attention is paid to the applications commonly used in the laboratories. Thus, the connection to the already existing laboratory IT infrastructure is taken into account in the standard to be developed from the very beginning. We expect from this standard a shorter preparation time through automatic data transfer. This also reduces errors since data no longer has to be transferred manually. But even after processing, the automated transfer of the result data should save valuable time. The automated interfaces also allow progress to be recorded more promptly.
Yeah, the objective of the LADS standard is therefore a very big sentence. The objective is to create a manufacturer-independent open standard which comprehensively takes on board the requirements of various branches, disciplines, and business processes and is sustainable and adaptable to future requirements in the field of digitalization and automation. As I said, it's a big sentence. There's a lot of information in there. Let's focus on the most important bits, and this is that we want to have a manufacturer independent and open standard. So it should be something that can be applied across all the brands, all the different devices that are used in the lab. Also, it should have in mind always the user requirements, so what is needed for the different workflows in the labs, and should not be fixed to one situation that maybe was identified in the case study here or there, but should be sustainable and adaptable so that it can not only be used today, but also in the future. So what is the current situation in the labs? We have a variety of highly specialized devices that come from many different manufacturers and have many different interfaces. Of course, it's very tricky to have one generic approach for all of them because all these specialized devices have different functionalities, and all the tasks that they do result in different data that in the end needs to be somehow recorded and processed. Fortunately, we're not the first to think about standardization in this field, and there is some existing knowledge to build upon. In all current devices, we find more and more Ethernet-based communication. That is definitely a standard that is being used across all the industry, not only in laboratories, but also in the adjacent production environments. And also not only the communication is pretty much standardized, there are many approaches that standardize the data formats. So no matter what the devices do, there are many formats like animal or allotrope that allow to record the data in a structured and standardized way. What does, however, vary quite a bit is the actual communication protocols that the devices use on this Ethernet communication. Every manufacturer likes to have their own specialties there, and there is no clear approach to standardize that. So what is the approach of LADS? It's not to redefine communication interfaces or to develop new data formats. We make use of what is already there. But what we do look into is to create a common language, a common information model or a communication protocol that all the lab devices can share. And there, we also don't want to reinvent the wheel. So we have looked around what is commonly used in other branches. I've mentioned the very important production field where many of the lab processes end up afterwards. And that is more and more focusing on OPC UA. It's an established technology stack that is building upon Ethernet communication and is really more and more established in the industry. What we also will do is not consider all these little details that make each of the specialized devices special, but we will focus on a common denominator that these devices have. We will be device type agnostic, so not specify how each individual bit of a specialized device needs to be called in this communication protocol, but actually define a generic way on how these devices can describe their functionalities and which parameters they can detect.
As mentioned before, LADS will be used based on OPC UA. OPC UA itself is a successfully used and established standard in the field of industrial automation. The focus of OPC UA is on machine-to-machine communication. OPC UA itself is platform independent and it's already used on many operating systems. Also, numerous embedded systems are supported. A major and comprehensive security concept is a great advantage with regards to authentication, authorization, data transmission, and service availability. OPC UA is based on a standardized technology stack. So-called companion specification allow for subject-specific extensions of these standards, and there is already a large number of different industrial specifications for a wide range of applications. As already mentioned before, LADS aims at a device and data independent approach. This means that a wide variety of devices or software applications should be able to be integrated. Appropriate agnostic interfaces are defined for this purpose. On the one hand, interfaces which enable device integration, and on the other hand, interfaces which also allow the integration and further processing of different data formats.
After we have taken a look now at the technology that will be underlying our standards, it's important to call back into our memories the different use cases that that standard can be used for. I've mentioned in the beginning, it's supposed to be also for the future. So the list we have here is, of course, a start. It's never meant to be the final story. We work in an iterative and agile approach and are always listening for customers' input to expand that. But definitely very important use cases we will have from the beginning are, for example, remote alarms and notifications and remote monitoring, so that we can keep track of what the devices are doing. Of course, when we keep track of that, we also want to have the possibility to control them remotely. That can be just the change of a set point or even the management of programs that more complex devices have to orchestrate the workflows in these labs. We want to be able to retrieve and manage the results that come from that, but also, of course, make sure that all the devices are always in perfect order. So not only look at fleet management, but also at preventive and predictive maintenance. From the long list of use cases we want to support from the beginning, I want to give you one closer example. I have here on this slide an overview of what the current situation in a modern bioprocessing lab might be. You already see that there is not only many different devices involved, but that there is a little man running around a lot with many, many arrows. So what the person has to do in the lab, for example, is to get his sample in the beginning, his strain from the freezer. The strain needs to be incubated in an incubator shaker. He has to take samples to see what is going on in these shake flasks in a spectrophotometer. When all is going well, this pre-culture gets transferred into a bioreactor. Again, more samples are being taken, maybe analyzed with HPLC. When the process is finished, the cells or their products can be harvested. Maybe there's a centrifuge step involved. And last but not least, all the equipment used needs to be cleaned. So a laboratory dishwasher might come in order. And at all these spots throughout the whole workflow, there is information being generated that is important to the success of the experiment. Even if it's not directly measurements taken from the bioprocess, it's also important to keep track of what the freezer temperature was actually the strain stored in proper conditions, what was the spectrophotometer calibrated to, and did the centrifuge really work as long as I wanted to. Currently, there are some systems that have proprietary software already running on a dedicated computer, for example, here the bioreactor and the HPLC. And if I'm lucky, the information can already be transferred to a LIMS or to my PC in my office, so I don't have to run back and forth to see what's going on. But for all the others, you see the person has to run around, take notes in a lab notebook, maybe transfer data on a USB stick, and it's very, very tricky to automate all that. There are some approaches where engineering companies build specialized interfaces. They need to write drivers, but it's a lot of work that needs to be done, and there is no way when a new device is added or one of the components is replaced to get it up and running fast without any interaction. So how will the situation change when we introduce LADS? We have the vision that all the participating manufacturers will equip their machines to be able to communicate over this new standard. You see it's an Ethernet-based communication, so all is connected to the network that the customer already has. And because they all speak the same language and can describe what they can do, it's very easy for a LIMS to access all the information that is generated on all these devices. It can not only be read and used for reports, but if the devices allow for remote control, I can also influence them not only from in the lab, but also from my office. Even if one of these devices would be replaced, for example, the shaker is obsolete and I need to get a new one, if it supports the same standard, it will be very easy to integrate it without the need to develop new drivers or to hire expensive engineers.
The working group has already done some preliminary work to be able to start the development of the standards. Such preliminary work, for example, is the collection of use cases that we have had already completed. And also, we are already worked on the high-level concept and selected meaningful architecture approaches for the standard. And within this quarter, we want to start the specification. The specification should be finished nearly to the first quarter of 2022. And so we want to start at this time with the reference implementation. And when the reference implementation is completed, we need additional time end of 2022 to provide all documentation and paperwork that are necessary to introduce such a standards. And so we hope that end of 2023, we can make the standard available for the worldwide use. Who is behind LADS? So LADS, it's organized and managed by the SPECTARIS. The SPECTARIS is the German Association for Optics, Photonics, Analytical and Laboratory Equipment. And it's built on support of 400 members. And they're also representing the interests of more than 90 German manufacturers of analytical and laboratory equipment. The SPECTARIS was so kindly to form the core group to develop these standards, and still we are a lot of members of these working groups, but we still are looking for further members for further contributing and observing members, for example. And additional, we are also looking for further input of customers so that we can ensure that we develop a standard that fulfills the expectation of the market. So furthermore, there are also a lot of manufacturers involved in the developing of these standards, and maybe one of the listeners can be the next and join our team.
This already brings us to the end of our brief introduction of LADS. I hope that in the beginning we could show why there is a need for more standardization. Heiko explained how we can save money in laboratories if we have a communication standard that allows us to automate the workflows. We have also highlighted what we are in effect doing in the LADS project. We're working on an open industrial standardization of the interfaces in laboratories that should be independent of what device types are used, device agnostic, and built on an established technology stack that is also used in other parts of the industry, like in production processes. We have chosen OPC UA for that, and we have shown you why it is a good choice to build on that. In the example with the bioprocessing lab, we have shown how easy it will be to connect devices working with the LADS standard together, how easy it is to integrate them into supervisory software, or even interchange them when a better device supporting the same standard becomes available. With all that, R&D labs will be able to save costs because they can automate the workflow, orchestrate the workflow, and prepare for a faster transfer also to the subsequent production processes if needed. In order to be successful, any standard must fulfill the requirements that actually arise in the labs. So I want to point out again that we listen to customers and to users what they actually need, and have chosen the use cases that we have heard most often of to be implemented first. But we are always looking, and Heiko mentioned that just now, not only for other companies that are interested in joining our efforts, but also for feedbacks of end users, what they think they will need in the future, so we can adapt the standard development to go in the right direction. If you want to find out more about this, the most important bit is the website link on the very bottom part of this slide. We have a website set up that describes in more detail also the technology behind our approach, and where you can download flyers and white papers outlining the LADS standard. Of course, we are also there for you, that is Heiko Oehme and I, the two speakers of today, but also Birgit Ludwig and Krasimira Marianska of SPECTARIS, who will answer all your questions that you might have. So thank you for your attention, and we're looking forward to hearing from you. Bye-bye.